Hi, everybody. Part 3 of rational functions deals with horizontal asymptotes. So we're going to be learning how to find the horizontal asymptote of a rational function. The horizontal asymptote is a little bit more complicated. Let me show you the rules, and I'll summarize them again at the end of the screencast. So I'm actually going to read through this. When the numerator and the denominator of a rational function have the same degree, the line y equals a over b is the horizontal asymptote, where a and b are the leading coefficients of the numerator and the denominator, respectively. When the degree of the numerator of a rational function is less than the degree of the denominator, the x-axis, or y equals 0, is the horizontal asymptote. And lastly, when the degree of the numerator of a rational function is greater than the degree of the denominator, there is no horizontal asymptote. All right, that's a lot to take in, and I understand that. So let's go through and look at some specific examples. So in our first example, f of x is equal to x minus 2 over x plus 2. The first thing we want to do is find the domain of this function. So the domain is negative infinity to negative 2 and negative 2 to infinity. Remember, x cannot be equal to negative 2. So then do you know what the vertical asymptote is? Well, hopefully you learned from the previous screencast that the vertical asymptote is x equals negative 2. That's the vertical line that the graph isn't going through. We were asked to find the horizontal asymptote. So what I want you to do is I want you to investigate this a little bit and graph this function in your calculator. So if you graph it, it looks like this. And the vertical asymptote, we know. The vertical asymptote is that vertical line that the graph isn't going through. But what about the horizontal asymptote? Can you see that in the graph? That horizontal asymptote is this orange dotted line that is on our graph. It's superimposed there. The equation for that horizontal asymptote is y equals 1. Now, where that comes from is from the definition that we just talked about. See, in this example, the top and the bottom, the numerator and the denominator, the x terms both have a degree of 1. So when the degree of the numerator and the denominator is the same, the horizontal asymptote is the quotient of those lead coefficients, a over b, if you'll remember. So, see, f of x is equal to 1x minus 1 over 1x plus 2. And the leading coefficients are both 1. And 1 divided by 1 is 1. That's why the horizontal asymptote is y equals 1. Let's look at another example. F of x is equal to x minus 1 over x squared minus 4. Just like before, determine the domain. So the domain of this function is negative infinity to negative 2, negative 2 to 2, and 2 to infinity. I should have showed you this factored, but you know x squared minus 4 is x plus 2 and x minus 2. So 2 and negative 2 are not elements of the domain. Now, what would be the vertical asymptotes then? And those are also x equals 2 and x equals negative 2. Look at the graph, and you can see those vertical asymptotes. Okay, what does the horizontal asymptote look like? Where's that horizontal line that the graph doesn't seem to be going through? Except here, I acknowledge that, but you can see it's hugging this line on the left side of our graph and hugging the line on the right side of our graph, right? So that is the horizontal asymptote. Now remember from that first screen, the definition is when the degree of the denominator, see the degree of the denominator here is 2. When the degree of the denominator is greater than the degree of the numerator, the horizontal asymptote is y equals 0. It's the x-axis. So the horizontal asymptote is y equals 0. Okay, one last example. So in this example, f of x equals x squared minus 4 over x plus 1. Once again, we're going to determine that domain first. And it's all reals except -1. And the vertical asymptote is x equals -1. Check out this graph, though. That's a little weird looking, huh? What do you think about a horizontal asymptote here? Do you see one? So in this example, the degree of the numerator is greater than the degree in the denominator. And when that happens, there isn't a horizontal asymptote. So their horizontal asymptote, there isn't one. Okay, that's basically what was covered in those examples, the 3 different situations, when the degree on the top is bigger, the degree on the bottom is bigger, and the degrees are the same. I'll summarize it shortly, but I want you to see something. There is an asymptote here. It's not horizontal and it's not vertical, but this other asymptote is called an oblique asymptote. This rational function has an oblique asymptote. I want to examine a little bit further this idea of an oblique asymptote. So when the degree of the numerator is greater than the degree in the denominator by 1, okay, so the difference between these two degrees can't be more than 1. And when the degree on the top is bigger by 1, there is an oblique asymptote. To find the oblique asymptote, we divide the numerator by the denominator. So I'm going to divide x plus 1 into x squared minus 4. I need to put a 0x term in there, remember? Because I have to have all the terms represented. X to the second, x to the first, x to the 0. And when I actually do that division, then I see that I get a quotient of x minus 1. And the quotient is my oblique asymptote. So the oblique asymptote is y equals x minus 1. Now, sometimes students worry about that remainder. We're just going to ignore that remainder. The remainder is insignificant. You'll learn why when you learn about limits in calculus. But basically what we're saying is that equation is really x minus 1 minus 3 divided by x plus 1. And as x gets really big, that -3 over x plus 1 gets really insignificant. So we ignore it altogether. So the equation of the oblique asymptote is the quotient, what's on top of the fraction bar when you do long division. So it's y equals x minus 1. Okay, let me summarize everything we've learned in this screencast. So when the degree in the denominator is equal to the degree of the numerator, the horizontal asymptote is the quotient of the lead coefficients of the numerator and denominator, y equals a over b. Second case, when the degree in the denominator is greater than the degree in the numerator, so the degree on the bottom is bigger, the horizontal asymptote is y equals 0. If the degree of the denominator is smaller, that means the degree on top is bigger, there is no horizontal asymptote. There might be an oblique one, and there's an oblique asymptote if the degree in the denominator is smaller by 1. And to find that oblique asymptote, we're going to divide the numerator by the denominator. Okay, that's about sums it up. Good luck.